Hi, and welcome to the lecture on section 3.5 transformations. So this is a little bit of a longer section, so I think there's going to probably end up being 3 videos for this. In this first video, we're going to talk about the graphs of functions using horizontal and vertical shifts. Then we will talk about reflections using horizontal and vertical axes. We will determine if a function is odd, even, or neither. And we will graph functions using compressions and stretches, and we will do some combination of transformations. All right, so let's get started. The first kind of transformation we're going to talk about is the shift translation. So let's look at our first example. Let f of x equal the square root of x and g of x equal to the square root of x plus 2. And note that the plus 2 is not underneath the square root sign. We're going to graph these using Desmos. Then we're going to write a sentence comparing the graphs of these two functions. Then we're going to graph h of x equal to the square root of x minus 3 and see if we can make a prediction. So let's go ahead and go over to Desmos. All right, here we are in Desmos. To get here, go to desmos.com. I can actually do this again, desmos.com. Sure, why not? And where it says Graphing Calculator, just click on Graphing Calculator. You can see I've actually logged in with my LinVention Google account, and I recommend you do that too to save graphs if you want to, but you don't have to. So let's go to Graphing Calculator, and the first function we're going to graph is f of x equals the square root of x. To do square root, you just start typing square root, SQRT x. And you can see over here on the side is square root of x, the graph. You can move it around with your mouse, you can zoom in and out using touchscreen controls, however you want to do it. You can scroll the mouse button. It's a really great graphing tool. All right, so we wanted to compare this to a different function, g of x equals square root of x, SQRT x. I don't need parentheses. Now to make sure if I just type plus 2 now, I'm still under the square root sign. I don't want that. So I hit the right arrow that gets me out from under the square root sign, and then I type plus 2. And there we are. All right, so the red is our original graph, root x, and the blue is the g of x, square root of x plus 2. And you can see that g of x is shifted 2 units higher at every single point than the red graph. And this makes sense because we take x, we compute its square root, that's the red function, and then we add 2 to it. So every single output value has a 2 added to it. Let's go ahead and think about that function h of x equals the square root of x minus 3. See if you can make a prediction in your head about what that would be like. And now let's try it on Desmos. Square root of x outside the parentheses minus 3. And hopefully you predicted that it would be shifted down 3 units. If you didn't, no problem. It's what math is all about, trying things and seeing how they turn out. So this is called a vertical translation. When you add things to the outside of the function, not inside the square root sign, but outside, if you add a positive number, it shifts up, and if you subtract a number, it shifts down. All right, so now that we've come back to our notes, let's write our sentences. So we did graph these two using Desmos, and let's write a sentence comparing the graphs of the two functions. The graph of g, oops, I might want a pen to write with here. The graph of g is 2 units higher than the graph of f. And the graph of h of x will be the graph of f shifted down 3 units. All right, so those are vertical translations. And here is the rule, just so you can put it down in your notes. Vertical translations shift the whole function up or down. It is added on the outside of the function, so not inside the f of x, on the outside. If d is positive, it shifts up d units. If d is negative, it shifts down d units. Let's talk about horizontal translations. For this time, we're going to use the function x squared. We're going to graph f of x equal x squared and g of x equal to x plus 2 squared. We're going to graph these using Desmos and write a sentence comparing them. Then we'll compare it to h of x equal to x minus 3 squared. Now notice when you look at what's happening with these functions, what's happening, the x plus 2 is on the inside of the function. The x minus 3 is on the inside of the function. Let's see how that turns out with the graphs. All right, let's go ahead and graph f of x equal to x squared. And to do the exponent, I use the caret button above the 6, so I hit x, shift 6, and that got me up there, and then squared. And let's compare that to x, gosh, I don't remember what I was comparing it to. Hang on a sec. X plus 2 squared. Parentheses, x plus 2. Now I do my shift 6 for my caret, squared. All right, what happened here? Well, the purple is our original graph of x squared, and the black is our graph of x plus 2 squared. And you can see that it shifted to left horizontally. Let's see if we can make sense of this. So if we think about adding 2 to the input of our function, if we add 2 to the input of negative 2, we will end up at 0. So what happened to the original function at 0 is now happening 2 units faster with the function, the shifted function g of x. What happened at the original function at 1 now happens with the shifted function at 0, 2 units faster. That's the way I like to think about it. Can you think about in your head a prediction of what our function h of x, x minus 3 quantity squared will look at? Let's take a look at the graph. Shift 6 squared. Oops, that's cubed. Squared. All right, hopefully you realized, or you thought, predicted, that x minus 3 squared will shift the original function 3 units to the right. So what happened with f of x at 0 is happening with h of x at 3. So if we put in the input of 3 here into our shifted function, we subtract 3 from that input, that's what happened originally with function f of x at 0. All right, so we graph these using Desmos. Let's write a sentence comparing the graphs of these two functions. The graph of g is the graph of f shifted 2 units left. And the graph of h is the graph of v shifted 3 units to the right. And here is our rule. Horizontal translation, shift the whole function left to right. Now this one some people think is a little counterintuitive because when you subtract, you move to the right, and when you add, you move to the left. But just think about things happening faster. That's the way I think about it in my head. Or remember that it's the opposite of what you think it should be. However you want to make that work out in your head. So if x minus c, if c is positive, we're going to shift to the right. And if it's negative, we're going to shift to the left. So that means if we have x plus something, it's going to be a left shift. Hopefully that made sense. Let's go ahead and practice looking at these graphs. This is just for some function f of x, and let's write down what kind of a shift do we have. We can double check these. So f of x plus 3 is going to be, since it's inside, it's a horizontal shift. And since it's plus 3, it's going to be 3 units to the left, right? It's going to happen 3 units faster than the original function f of x. And x minus 1, that's also a horizontal shift because it's inside the function. Horizontal shift, 1 unit to the right. F of x plus 7, now this is outside the function, so this is a vertical shift. Up 7 units. And f of x minus 2 is a vertical shift. Down 2 units. All right. Let's practice writing some transformations. So let's go ahead and look at this function f of t equals t squared plus 2t minus the square root of t. And let's do these different transformations. If we wanted to shift that function f of t left 4 units, what would we do? What would we do to shift it left 4 units? we would do f of t plus 4, right? And we don't need to multiply that all out right now. We just write f of t plus 4. If we want to shift it up 7 units, f of t plus 7. Outside, right? That's an up, so that's an outside the function. If we want to shift it to the right 6 units and down 3, we're going to go f of right 6, t minus 6, down 3, minus 3. That went a lot faster than I expected. So I guess we're not going to, I'm just going to keep going. It says video 2, but let's ignore that. This is still video 1. Video 1. Let's talk about reflections. There's 2 ways to reflect functions. Minus f of z is a reflection over the horizontal axis. So you compute f of z, that's your output, and then you take the opposite. So if it was at positive 3, now it's going to be at negative 3. F of minus z, so inside, is a reflection across the vertical axis. So if we put in 2 as z, we're going to first take the negative of that, put it over to negative 2, and that's why everything's being shifted horizontally across the vertical axis. So let's take a look at how this works out. We're going to look at the example f of x equals the square root of x. First, we're going to find minus f of x equal and call that function h of x, and we'll graph it on Desmos. And then we'll find v of x, and that's f of minus x, and find it on Desmos. So there's 2 ways we can do this. We can practice doing this algebraically first. So minus f of x would be equal to minus square root of x, right? So the function h of x equals minus the square root of x. And v of x equals f of minus x, which is equal to the square root of negative x, right? So those are the 2 other functions we're going to graph and compare to f of x in Desmos. Let's go there now. All right, here we are in Desmos. Let's graph our reflections. F of x equals square root x. And h of x equals minus on the outside of the function, square root x. There we go, and you can see here's my original function in purple, and my reflected across the x-axis. So if I folded it on the x-axis, my reflected function across the x-axis is down here in black. What was the other one we wanted to look at? It was v of x, and that was equal to the square root of minus x. And now this one is over here reflected across the y-axis. So if we folded along the y-axis, you could see this. I just want to take one quick moment now to show you a really powerful thing that Desmos can do. So if this is your original function f of x, you can actually check transformations by just typing them into Desmos. So if I want minus f of x, I literally type in minus f of x, and sure enough, there's my new function. I didn't have to go compute it. It's good practice algebraically, but I didn't have to. If I want to know what is f of x plus 2, which I hopefully knew was shifted left 2 units, I can just type that in and check it. Desmos is a really great graphing tool.